Map fans, welcome back. Today we're looking at LiDAR-based tree crown mapping in ArcGIS Pro and using RStats. This video is in reverse because nobody has an attention span anymore, and it'll be chaptered. First up I'll run the tool, then show you how to build the tool, then look at code changes that I made, and then we'll look at how we can get ArcGIS Pro and R talking together. Finally we'll look at data sources. I'll turn on my CHM or canopy height model and then open up the tool. This runs off an R script. For my input, I'll set my input canopy height raster, and then I'll set the minimum height for what will be described as a tree at 12 meters. For my outputs, I've got a point file, one for the tree tops, and then I'll also have a polygon file for the tree crowns, and that's what the tool is going to delimit. I'll hit save and then just hit run, and off it goes. Once the tool is run, I can add in the data that it has just created. And I'll go in here and add the crown polygon and the treetops point file. Okay, that. Then I can zoom in and check out what the tool has done. So the points are the highest point of a tree, and then the polygons are the tree crown. Now you may or may not get good results. There are plenty of things that you can change within the R script in order to get different results, and you may want to do some work on your LiDAR inputs as well before running the tool. But you can see this gives us a starting point, and it doesn't look too bad actually. Now let's have a look at how we can build the tool. For me to get started on this, I followed an excellent tutorial by the Pennsylvania Elevation Working Group and their Vegetation Network page. It was this tutorial, the LiDAR derived tree canopy heights using ArcGIS Pro. Now I did need to make some changes and put in some changes that I wanted to make as well to this tutorial, and so if you've used this previously, there'll be some tips on how to get this working in ArcGIS Pro. So let's have a look at how we can build that tool. Here I am back in ArcGIS Pro, and when you start a new ArcGIS Pro project, you will have a toolbox associated with your project. Here I've got Tree Crowns 01 ATBX. If I right click on this, I'm offered the option to create a new, and I'm going to go with a new script. Now this script could be anything. In my case, it's going to be an R script, and it'll ask for a bunch of things, general things, parameters, execution, validation. Now I'll show you what I set all of these to. So I've got this script already there. If I right click on that, I can go to properties, and you can see that I have the name, LiDAR Tree Crown Delineation, and the label, which has spaces in it. The name is what we can use programmatically to call this script if we'd like to, and the label is human readable, so you can change those accordingly. And the toolbox is just my default toolbox. I've not added a description because this title is pretty descriptive. Now when we get into the parameters are what we see when we open up the tool, and it allows us to add inputs, outputs, and change some settings. So here I've got 4 parameters. I've got the input tree canopy height raster, what data type it is, whether or not it's required, and which direction is it going to be in, input or output. I've also got the minimum tree height and then the shapefiles that I'm outputting to. Now these are different to what was suggested by the Pennsylvania Working Group. I've set these to be file types so that I can actually create these in the script. What I found previously using the boilerplate code from the Pennsylvania Working Group was that I needed these shapefiles to be created already, but I've changed the code accordingly. So once you've done that, you can go to execution, and then you just need to point ArcGIS Pro or this tool to where your script is stored. And so mine's just called Treetop Tool, and it's in R. Now I've changed the script quite substantially from what the Pennsylvania Working Group had out there, and I'll run through that in the next section. Once you've done all of that, you can just hit OK, and then when you double click your LiDAR tree crown delineation, you can see these parameters are available now. So the input for the height raster, the input for the minimum tree height, and then our output files as well. Code doesn't make for a very interesting video, so if you'd like to download this code, I'll provide a link in the description below. A couple of things that I did add was checks to make sure that the packages we are installing are not installed already, and if they are, we can skip installing them. I found that was throwing an error with Forest Tools, where ArcGIS Pro would tell me that Forest Tools was in use, and so it couldn't use it. The other error that I was getting was to do with the output files, and I was getting an array out of bounds or subscript out of bounds. And I think that's because the Pennsylvania code expects the shapefiles to exist and to have the right attributes. In this code, what I've done instead is created the shapefiles from scratch, and that takes that input file path that we had and creates a shapefile wherever we decide to save it to. If you don't understand something in this code, then please do use the docs. So for example, this bit here to create the view window, I can't remember what that is, but let's have a look at this bit. What does min, win, neeb mean? No idea whatsoever. I didn't write this package. So if we go from here and have a quick look at the docs, if you just search on Google for Forest Tools docs, you will get this brilliant PDF, and that tells you all about all the things in that code. So min, win, neeb, what the heck is that? Let's search for it, and it'll take us right down to this VWF, which is in fact the variable window filter, implements a variable window filter algorithm. Excellent. And it takes these arguments, one of which is min, win, neeb, and that can have queen as a string. What does that mean? If we go for the arguments, it is a character argument, and it'll define whether the smallest possible search window for 3x3 should use a queen or a rook neighborhood. If you don't know what that is, then why don't you look it up? If you do get stuck, do get in touch, use the comments below. Please give me more information than this doesn't work. I need to know what you're trying to do, what section of the video you're at, what you've tried, what hasn't worked, what you're expecting, and what's actually happening. Any error messages need to be included as well. Proper error reporting is real important. Now the next question is, how do we get ArcGIS Pro and R talking to each other? Well, first things first, you will need to install R. So if you just have a look for RStudio, if you stick it into a search engine, then you will see the simple recipe. 1. Install R. So you can click this, download and install R. 2. Download RStudio Desktop for Windows. Install those, get those running, and then you can have a look at what you can do within ArcGIS Pro. Back in ArcGIS Pro, all you'll need to do is go to Project and then go to Options. Within your options, you want to go to Geoprocessing, and right down at the bottom you should see R ArcGIS Support. Now it should automatically detect your R home directories. You can set these to whatever you want if you've got multiple installations, and you can see here that I have installed ArcGIS Binding package version 1.0.1.306. 306 has some updates I think people were having a bit of trouble with previously, but 306 appears to have fixed those. And if you don't have ArcGIS Binding installed already, this doohickey should allow you to install that without a problem. Oddly enough, this appears quite seamless. It didn't take me long to get this set up. Again, if you are having problems, don't forget to error report correctly and give as much information as possible for troubleshooting. So once you've got that set up, you should be able to run your scripts without too much trouble. Now let's have a look at data sourcing. Here in the UK, we're very lucky to have the National LiDAR programme, and you can access this through DEFRA's Data Services platform. Now if I zoom into the area that I'm interested in, each of these tiles will be a tile of LiDAR in most cases. I can just select draw a polygon of where I'm interested in, and then I can get the available tiles. The tiles that I wanted for this were a DTM, a digital terrain model, and the first return of the DSM. I'll show you the difference between these two in a second, and I just went to download all, unzip them, and then I can bring them into ArcGIS Pro. Back in ArcGIS Pro, here is the DTM. This is the digital terrain model, and this will remove all vegetation, buildings, anything like that. All we're interested in here is the very surface of the earth. Now if we have a look at the DSM, I'll put this on top, and now you can see we have all the trees and buildings and things like that on top of them. Now the interesting thing we can do with this is we can do a subtraction. So if we take the digital surface model and we subtract the digital terrain model, then everything's effectively on a level playing field and looks like this. Aha! Now we don't need to worry about elevation getting in the way, and the height of our trees should be leveled off, as it were. The next thing that I did with mine was just go for a smaller area. I clipped it just for processing, cut down on processing times, play around with a few settings, see how things worked and what was giving me a good output. I always recommend you do work on a smaller data set rather than going for the whole hog immediately, because processing time may sap your soul. Anyway, that's all for today. Thanks very much for watching. Don't forget to leave comments and hit the like button, and don't forget to subscribe. It's been a pleasure as always. Happy mapping.